Chapter 2, Reasoning and Proof, Section 3, Biconditionals and Definitions. So in the last section we talked about conditionals, if-then statements. A biconditional is the conjunction of the conditional and its converse. So for example, let's say we have the two simple statements where P is two angles are congruent and Q is two angles have the same measure. This first example, P implies Q, is the conditional. So it would be written as, if two angles are congruent, then they have the same measure. The converse means you just switch the Q and the P. So if two angles have the same measure, then they are congruent. The biconditional is written with this double-sided arrow. So it basically means you're reading the truth value forwards and backwards. So two angles are congruent if and only if. This is a big hint that it's a biconditional. If and only if they have the same measure. So that's saying two angles are congruent if they have the same measure, and if they have the same measure, the angles are congruent. So it works forwards and backwards. Now, a good definition is a statement that can help you identify or classify an object, and a good definition has several important components. So it's clearly understood terms, so they're commonly used or have already been defined. It's precise. You avoid words such as large, sort of, almost, approximately, words like that. And a good definition is reversible. So a good definition is a biconditional. So you can write it as a true biconditional, which we're going to get some experience with. So here we have our truth table. We talked about conditionals, inverse, converse, contrapositives, and now we're talking about biconditionals. We're going to see what the cases are when we start off with two true statements, a true and a false and a true, and a false and a false. So let's start with the conditional statement. When something true implies something true. So when you start with a hypothesis that's true and the conclusion is also true, the whole statement is true. When you have something false imply something that's false. So false implies false. In a real example, the inverse is also going to be true. The converse, something true implies something true. So overall, that's going to be true. The contrapositive, in this case, something false implies something false. So again, that's going to be true. Now, the biconditional said that it's the conjunction of the conditional and its converse. So true and true means that the biconditional is also true. So that whole top line would be true. Now in the next example, the conditional is true implies false. Well, when something true implies something that's false, the overall statement is false. However, in the next example for the inverse, when something false implies something that's true, the end result is a true statement. The converse, false implies true. In this case, when something false implies something that's true, the end result is true, so the overall statement is true. And not Q implies not P. So true implies false, which means the overall statement is false. Finally, the biconditional, it's the conjunction, so and, of the conditional and the converse. So we have false and true, so the overall biconditional is going to be false. So finally, these last two rows, for the conditional, when something false implies something true, we get a true. something true implies something that's false, we get a false. For the converse, Q implies P, so true implies false is false. For the contrapositive, false implies true is true. And the biconditional, we're looking at the conditional and the converse, so true and false gives us false. Finally, false implies false is true. For the inverse, true implies true is true. For the converse, false implies false is true. For the contrapositive, true implies true is true. And then we look at the conditional and its converse, so true and true is also true. So just to simplify it a little bit, when you're talking about a conditional, an inverse, a converse, or a contrapositive, when you have something true implying something that's true, the overall statement is true. Same thing when you have something false implying something that's false, the overall statement is true, because if this isn't true, then the second statement isn't true. So the overall statement would be true. Now, when you have something false implying something true, the end result is true, therefore the overall statement is true. So the only false overall statement that you're going to get is when you have something true implying something false. The overall statement is going to be false. And then obviously when you have the biconditional, you're going to look at the conditional and its converse. They should either both be true or both be false in order for the biconditional to be true. We'll do an example with these in class, writing them and determining truth value, but it would be helpful for you to be familiar with the truth table, or if it's easy for you, try to memorize it so you can determine the truth value on a test or a homework problem.